Okay, this is for today's lesson in pre-calculus. I want you to take out your notebooks. You're going to be taking notes along with this video. Pause the video as needed. Please write the formulas, the equations, and such that we go through with the explanations that I give you. You want to start your notes with drawing a random triangle. It's just some scalene triangle. I happen to draw a scalene acute triangle here. We always want to have a common way we're going to name our triangle for our lessons. So I'm going to call this triangle ABC, meaning the names of the four vertices, and the sides opposite each vertex or each angle has the same letter but in lowercase. So we have angle A and side A, we have angle B and side B, we have angle C and side C. We're going to take measurements. We're going to be given some measurements in a triangle, and we're going to compare the sine of the angle to the side opposite. So I'm going to look at angle A and side A, and I'm going to compare the side length compared to the sine of angle A. And I would have numbers here. I'd put whatever this is, 7 divided by sine of 23 degrees, whatever is given in the problem. And I plug that into my calculator and I get a decimal answer. And then I go back to the triangle and I do the same thing with a different side and the opposite angle. So I'm going to compare side B to the sine of angle B. And what we find out is when you plug this in the calculator, you're going to get the exact same decimal answer. Now, A and B are not equal. These are not the same length. Angle A and angle B, they're not the same measure. But this ratio of the side compared to the sine of the angle opposite is going to be the same as the other side to its sine of its angle opposite it. Well, if this is true with A and B, it's also true with side C compared to sine of C. And this, which is pretty amazing, is called the law of sines. So we're going to want to memorize this concept where it's a side being divided by the sine of the opposite angle. Now, with ratios, we can flip these. And as long as we flip every single one of those ratios, it's still true. So I could compare the sine of angle A to the side of A, and then look at the sine of angle B compared to side B, or the sine of angle C compared to side C. And once again, whatever I get for this decimal answer is going to be the same for each one of these ratios. And again, this is called the law of sines. Memorizing the formula is one thing, but how do you use it? So let's look at a couple of different examples that show different things that you'd be given and how we would use the law of sines. In our first case, we're going to have one angle and the side opposite. We always have to have one angle and the side opposite. And then we have to have one more piece of information. In this, which we're going to call case 1, we're going to have one more angle. So this is what we're going to have. We're going to have an angle and the side opposite and one more angle. It could be this angle up here that we called angle C, or it could be this angle down here that we called angle B. For our example, let's talk about angle C. So we have this angle. Now, if I look at this diagram and I think about geometry class, we called this configuration angle, angle, side. Because we have an angle and now it wouldn't have mattered if we'd had angle B, we would still have angle, angle, side. So if you have an angle and a side opposite and one more angle, we have enough information to do what is called solve a triangle. Solving a triangle means we're going to find all three measures of the angles and all three measures of the lengths. And once we have all 6 of those pieces of information, we have solved the triangle. We're already given 3 of the 6 pieces of information. We're given 2 angles and 1 side. So it's going to be no problem because we can find the next angle, the third angle, in this case angle B, by just taking angle A and angle C and subtracting those from 180, and then we'll have angle B. We'll now have all 3 angles and then 1 side. We're going to use that information with the law of sines to find the other 2 side lengths. Let's see how it's done with actual numbers. So here's an example. We have our triangle. This is typically how it's written in your homework and how I would write it on quizzes and tests. You've got a triangle with this configuration. We know to solve it, we need all three angles and all three sides. You have to be given, first of all, an angle and a side opposite. So I'm going to give you angle A and a side opposite angle, side A. And for this one, because we're doing case one, we need one more angle, either angle C or angle B. Well, we're going to give you angle C, 82 degrees. I'm now going to come down to my chart down here, fill out the given information. I know that I have angle A is 28 degrees, side A is 5, and we also know that angle C is 82. The first thing we want to solve for is the measure of angle B. We use a triangle sum theorem that said if you add up A, B, and C, we get 180. Plug in the ones we know, solve for the B that we don't, we get 70, and we write it in our chart. The next step is to use law of sines, where we are going to compare this side of 5 to the sine of 28, and that, whatever that is, it's going to equal the side of B compared to the sine of 70. We want to solve for B, so we multiply both sides of this equation by sine of 70. And now we type all of this into our calculator and hit enter, and we get 10.01. And we're going to write that in our chart. We're going to do the same process using angle A and side A to figure out side C using law of sines. So 5 compared to sine of 28 degrees is equal to C divided by sine of 82. Multiply both sides by sine of 82 degrees. Plug it into your calculator and you get 10.55. And we have solved a triangle. So this is using law of sines to solve a triangle. We've got all three angles. We've got all three sides. But this was just our first case where we had an angle, side opposite, and one more angle. In our next case, we're going to have an angle and a side opposite, angle A and side A. And instead of another angle, we're going to have another side, side B. Now, if you look at this configuration and think about geometry class and say, well, what was that? That was what we called angle side side. And with angle side side, we talked about in geometry class that there's ambiguity. And the reason there's ambiguity is this side A, I'm going to just say and draw another line in here. I'm going to draw another line that's exactly the same length as this side A, and it's going to go somewhere else in the triangle, and there it is. And go, oh, well, that means that we have we have this triangle right here that has the same angle side side. And so we have what we called ambiguity. Ambiguity of if we have angle side side, we could potentially have more than one triangle, one possible triangle to solve for. So let's go through a problem and see how we work it out. We're going to talk about how we know whether we have ambiguity or not. So first of all, to find out if we have ambiguity, we are always going to compare the opposite side, which we identify as side A, to the adjacent side, which we identify as side B. So we're going to compare them, and when side A is greater than side B, when the opposite side is greater than the adjacent side, it's no problem. There'll be no ambiguity. We just go ahead and solve using law of sines. When the opposite side and the adjacent side are exactly the same length, we have one and only one triangle. And that again, it's no problem. We just go ahead and use law of sines to figure it all out. Okay. Our third choice is the opposite, side A, is shorter than side B. And now, this is where we have these three different possibilities here, right? Well, now there are three different possibilities for this third case, when the opposite is shorter than the adjacent. And the first case is side A is so short, it doesn't come all the way down and touch side C. And therefore, we don't have any triangles at all. Is there a test? There is. There's a formula for a test to find out if this is the case. And that test is we do side B, the adjacent, times sine of angle A, and divide it by the opposite. So B times sine of A divided by A. We plug this into our calculator, and if we get a number that is greater than 1, then there's no triangles. If we get a number that is less than 1, well, we'll have to talk about that in a second. But right now, if we get this that's greater than 1, there's no triangle at all. The next case is there will be one and only one triangle. Well, even though side A is shorter than side B. Again, how will we know? I wish there was a test. It's the same exact test as this one, except for this case, B times the sine of A divided by A would equal 1. There'd be this, when you plug it in your calculator, it's just going to say 1. When that happens, we know there's one triangle, and it's a very special triangle. It is a right triangle. Now, I want to go up to this case up here. When the side opposite, side A, and the side adjacent, B, are both the same, then that means this is an isosceles triangle. We would have where two sides are the same length, and we'd have an isosceles triangle. In this case, side A is less than side B, and because B times sine of A equals 1, we get another special type of triangle, which is a right triangle. There's one more case, and that was, here we've got this test where B times sine of A divided by A is more than 1. Here we got B times sine of A divided by A is equal to 1. And our last case is when B times sine of A divided by A is less than 1. And when this is the case, there are two possible triangles. Like what I showed you earlier, where if we had this going on, we end up with two possible triangles. We have, like I said before, we have this small triangle right here, or we would have this big triangle here. Okay, so that's where we can say, oh, there could be two possible triangles. Okay, well, let's see what happens. What would make that happen? For the no problem ones, you just use law of sines. But what about this case right here? Case C. Case A doesn't matter. We do this, there's no triangle. So we're really interested in this case. So here we go. What happens when it is case C? When B times sine of A divided by A is less than 1. Well, here's a situation. The side opposite is less than the side adjacent. So I need to employ this law, B times sine of A. So I'm going to do 8 times sine of 32 divided by 5. And I find that that number is less than 1. Uh-oh. We have two triangles. Not two possible. We have two triangles. So we're going to use the law of sines, and we're going to solve for angle B. And we do that. Now, to do this, we would have multiplied both sides by 8, and then we would have to take the inverse of sine of all this mess, and type all of that into my calculator. So I can type sine inverse parentheses. Now you're going to do 8 times sine of 32. Don't forget the end of parentheses for that. And then you'll do divided by 5 and hit enter. And when you do that, you will get angle B. And when we do that, we get 57.98. So this angle is 57.98. We go ahead and we solve for the first triangle. We know that angle B is 57.98. So we use this angle B along with angle A to find angle C. And then we use law of sines to find side C. And we're done. We'll have solved the triangle. But where is the second triangle? Well, I want to remind you that what happens is when we do this, we're going to have another triangle in here like this. And while this angle here, the 57.98, that's an acute angle. I look over here now, this other angle is obtuse. And more importantly, something that we learned from geometry is this angle right here, not the 32, but this obtuse angle right here, plus this acute angle, those two angles will be supplementary, meaning they will add up to 180 degrees. So for triangle 2, we take the 57.98 and we find its supplement. What do we mean by supplement? We're going to call it B prime. And we know that B plus B prime equals 180. So I do 180 minus 57.98 and we get the supplement. And that would have been that acute angle. Now we have a different triangle that has an angle of 32 degrees, a side opposite of 5, a side B that is 8, and angle B that's 122.02. That's our second triangle. We're going to use that information to find angle C by subtracting from 180, both 32 and 122.02. We will find C prime, meaning our second triangle, and then we use the law of sines to find side C. So just to recap what we did. We used the law of sines to find angle B. Once we found angle B, we then solved for the triangle using law of sines. Then, secondly, we took angle B, we found its supplement, and then we solved for that triangle. And that would be solving for a triangle when there are two possibilities. And that's the end of our lesson for law of sines today. We will have another video lesson tomorrow, which will be for the law of cosines.